Hi, this is Algebra 1, Module 5, Lesson 7, the practice problems. First, we're going to review a little bit on the Pythagorean theorem. So, if you want to check to see if a triangle contains a 90-degree angle or is a right triangle, we can use the Pythagorean theorem. It goes as a squared plus b squared equals c squared, where c is the length of the longest side or the hypotenuse, and a and b are the length of the two shorter sides. So, it would look like here's a, B, and C. So we can test these by saying, is 9 squared is 9 squared plus 40 squared, does that equal 41 squared? And when put my calculator down, give me a moment to grab it. Okay, so 9 squared is 81. And so that equals, so 9 squared is 81. So let's put some space here. So it's 81 plus 40 times 40 is 1600. That's 1681. 41 times 41 is 1681. So this would actually be a yes. This one works. Okay, so let's try it here. 3 squared plus 4 squared, does that equal 5 squared? No, 5. Well, 3 squared is 9, plus 4 squared is 16. That equals 25, which is the same thing as 5 squared. So this one is also a yes. All right, let's try this one. 6 squared plus 7 squared, does that equal 8 squared? Well, 6 squared is 36, plus 49. 36 plus 49 equals 7, 80, 85? 85. Well, 8 squared is 64, so this one would be a no. All right, here. So now we want 20 squared plus 21 squared. Does that equal 29 squared? Well, 20 squared is 400 plus 21 squared equals 441. So together that's 841. So 29 times 29 is 841. So this one is a yes as well. Okay, so quite a few of these are working. Let's try this one. 9. Oh, scoot that over. Okay, so 9 squared plus 12 squared, does that equal 15 squared? 9 squared is 81, plus 12 squared is 144. So 81 plus 144 is 225, and 15 squared, I believe, is 225. Yep. So that one is a yes. Put it down here. Scoot that box up. All right. Let's try it with this guy. So 10 squared plus 11 squared, does that equal 15 squared? We just said 15 squared was 225, so 10 squared is 100 plus 11 squared is 121. That equals 122. So this one would be a no. That does not work. Okay, we'll try this one. 6 squared plus 8 squared, does it equal 10 squared? Okay, well, 36 plus 8 squared is 64. That would be equals 100. So that one is a, give me a box here. Yes, 10 squared is 100. All right, last one. 8 squared plus 15 squared, does that equal 17 squared? Well, that's 64 plus 225. That equals 289. 289, which 17 squared is 289. So this one's a yes as well. All right, so really only had a couple of no's in there. All the rest worked. Okay, we're going to solve these equations with substitution. So notice how we see there's a y equals in the top one. So any place we see this y, we can substitute in an x plus 1 in its place. So how I would write that is, go ahead and just get here. So I'm going to write this second one with the substitution. So x plus, can't write here. So x plus 2, and instead of y, I'm going to put x plus 1. I have to put it in parentheses because I have to do the x plus 1 first before I multiply equals 8. Well, I'm going to distribute. X plus 2x plus 2 equals 8. So I'm actually going to kind of do a 2 for 1 here. I'm going to subtract 2 from both sides and then combine these guys. So I end up with 3x equals, those cancel, 8 minus 2 is 6. So that means x equals 2. Well, if x equals 2, 2 plus 1, that means y must equal 3, right? 2 plus 1 is 3. And if I double check here, 2 plus 2 times 3, that's 6. So 2 plus 6 does equal 8. So by substituting it into there, I've also checked that as well. I did it verbally. You need to write that out. Okay, so the next one then, let's do, we have an x equals, so instead of the x, I'm going to substitute the 3 plus y. So let me erase that top one so I can see my numbers again. All right, so y plus 2, instead of an x, I'm going to put 3 plus y equals 7. This is called substitution. I'm putting that in instead of the x, so I only have one variable to work with. So again, I'm going to do kind of a 2. I can't do a 2 for yet. I gotta distribute first because my number's not separate, is it? All right, so y plus 6 plus 2y equals 7. Now I can do my 2 for. I'm going to minus 6 from both sides, and I'm going to combine these y's. So I have 3y equals 1. So in this case, y equals 1/3. Now if I substitute a 1/3 into right here, 3 plus 1/3, x has to be equal to 3 1/3. And so I can double check this. A 3 1/3 times 2 would be 6 2/3, right? And If I add a third to that, that would give me 7. So that works. All right, this one, I've got an x by itself. So instead of an x, when I see this x here, I'm going to substitute this whole thing. So that looks like 3 times 9 minus 2y plus 5y equals 20. So let's distribute. 27 minus 6y plus 5y equals 20. Okay, so now I want to um, get rid of my minus 27, and I want to combine these guys. So as I'm doing this, just got to be aware of my signs. So 20 minus 27 is a negative 7. Negative 6 plus 5 is a negative y equals negative 7, which to get rid of that, I can just multiply both by a negative 1 and get y equals 7. Well, if y equals 7, I can come back here and say 2 times 7 is 14. 9 minus 14 is a negative 5. So x equals negative 5. And I can double check. 3 times negative 5 is negative 15. Negative 15 plus 5 times 7, 35. Negative 15 plus 35 does give me 20. Just checked it. All right, here. So now I have a y equals, so I'm going to substitute for my y here. So 3 times, instead of y, I'm going to put 2x minus 4 plus 21x equals 15. Distribute 6x minus 12 plus 21x equals 15. I'm going to go ahead and add 12 to both sides, and I'm going to combine my x's. So I end up with 6x's plus 21 is 27x's equals, those cancel, 15 plus 12 is 27. So x equals 1. And if x equals 1, 2 times 1 is 2. 2 minus 4 is a negative 2. So y equals negative 2. I really should probably highlight my answers here. Use a different color to circle these other guys. And I can double check that. 3 times negative 2 is negative 6. Negative 6 plus 21 times 1 is 21. Negative 6 plus 21 does give me a 15. So if it works with both, we know it is a solution. All right, 2 more here. So now I have the x I'm going to substitute in for. So 3 times, instead of x, I'm going to put negative 1 minus 2y equal plus 5y equals negative 1. I distribute negative 3 minus 6y plus 5y equals negative 1. So here I can do my plus 3 both sides. I can combine these guys. So a negative 6 plus 5 is negative 1y equals, those cancel, negative 1 plus 3 equals a positive 2. So I actually want to divide by negative 1 equals y equals negative 2. Well, 2 times a negative 2, or negative 2 times negative 2 is positive 4. Negative 1 plus 4, that means x equals 3. So I'm going to go ahead and circle that. We'll double check. 3 times 3 is 9. 5 times negative 2 is negative 10. 9 plus negative 10 is a negative 1. Deal. All right, last one. I'm going to substitute in for the y. So x equals, no, not equals, x plus. X plus, instead of a y, I'm going to put 2x minus 3. I don't need parentheses this time because I'm not multiplying that y by anything. And that equals negative 5. So I can combine my x's. I'll go ahead and combine those and add my 3 at the same time. So I have 3x equals negative 5 plus 3 is negative 2 because those cancel. So x equals negative 2/3. So that means y must equal, if x plus y equals negative 5, well, negative 2/3, I need a negative 4 1/3, right? To get me to a negative 5. And so 2 times negative 2/3 is negative 4/3 minus a 3. So that's negative 1 1/3. Go 3 farther down, negative 4 1/3. All right. Tickets to a concert cost $10 in advance and 15 at the door. If 120 tickets were sold for a total of $13.90, how many tickets were purchased in advance? Well, we have 10 in advance plus 15 at the door had to equal 13.90. But we also know 120 tickets were sold. So that's advanced plus door equal 120, right? That was a total. So I'm actually going to solve this one for A. So I just need to subtract D from both sides. So I'm going to rewrite this as, we want to know how many, oh, how many were purchased in advance. So if I want the A to be isolated, if I want to solve for A, then I'm going to do the D here. So it's 120 minus A equals D, right? Because A plus D equals 120. So now I can substitute 10A plus 15 times 120 minus A equals 1390. Then I can break this down here. So 10A plus 15 times 120. 15 times 120 is 1800. 1800. Just going to double check and make sure I typed that in correctly. Okay. Minus 15A equals 1390. All right, so now I'm going to do my two things. I'm going to combine my A's and I'm going to subtract 1800 minus 1800. So I have 10A minus 5A, 15A. So that's a negative 5A equals 1390 minus 1800 is a negative 410. If I divide both of those sides by a negative 5, I get 82, positive 82. So 82 tickets were sold in advance. So that's how we used our system of equations to be able to solve that. All right, solve the following inequalities. Write the solution set in interval notation and graph the solution set on the number line. So I need a little bit more space for these. So 4x plus 10, I'm going to see if I can write them down below here. 4x plus 10 is less than 2x plus 14. Okay, so I'm going to subtract 2x from both sides, and that cancels. So then I'm going to subtract 10 from both sides, so that cancels. So that leaves me with 2x equals 4. So x equals 2, which is not equals, it's actually less than, right? So if I go back up here, x is less than 2. So I'm going to go to 2 on the number line, open circle, and goes this way. And interval notation would mean I go from negative infinity to 2, and neither one of those is brackets because it's not equal. Okay, so let's do the next one. It is 2x plus 6 is greater than 55 minus 5x. So to solve this one, I'm going to take away 2x from both sides, and I'm going to subtract 55 from both sides. So then that cancels. So 6 minus 55 is 49. Negative 49 is greater than, well, that's a minus 5, so it's a negative 7x. So divide both sides by 7, and it's a negative, so I got to flip my sign here. So I have a positive 7, so x is greater than 7, which means up here on my graph, it's an open circle because it's greater than, it's not equal. And then my interval would be 7 comma infinity because I can any number greater than. All right, 18. We have 2x over 4 plus 3. Oh, my parentheses should go around all that. Is greater than 6x minus 1. Right now, I think I'm going to go ahead and divide out this 2. If I divide 2 from both sides, that will cancel and that become a 3. So I'm left with, scroll down a little, need some space, x over 4 plus 3 is greater than 3x minus 3. I'm going to go ahead and distribute that. So I need to subtract 3 from both sides to get that out of the way so I get my fraction taken care of. So x over 4 is greater than 3x minus 6. I need to times both sides by 4. Okay, getting messy. So x is greater than, I'm going to distribute 4x, no, 12x. Make sure 4 times 3 is 12x minus 24. So I need to subtract 12x from both sides. So negative 11x equals negative 24. And so divide by negative 11, not equals. There. Just a greater than, right? Yep, greater than. Divided by negative 11. So x, I divided by a negative. I got to flip the sign. 24 elevenths, which is like 11, 2, and 2 elevenths. So let's see here. So a little bit bigger than 2. And I just said x has got to be what? Less than. Okay, so open circle, a little bit above 2. And we've got to be less than. So we're going this direction. So again, my interval Since it's got to be less than, it's negative infinity to 2 and 2/11ths. And my last one. Oh, I didn't write this one in here. X is greater than 7, and this one, X is less than 2 and 2/11ths. All right, my last one on 19. Let me see if I can have some space here. 9x plus 4. Uh, 9x plus 4 and is less than or equal to negative 2x plus a half. Negative 2x plus a half. All right, so I'm just going to distribute out this side, leave this one alone. Negative 2x minus half of 2 is 1. So now I can, let's add 1 to both sides. Add 1 to both sides. That cancels, and then we'll subtract 9x to both sides. That side cancels. Now we have 5 is less than or equal to negative 11x. And so I've got to divide by negative 11, which means my sign flips. So x is greater than, but less than or equal to 5/11ths negative. So x is less than or equal to negative 5/11. So that's about a half on here, and it's equals. So it'll be about right there, and it's less than. So we're going to go this direction. And so our interval would be negative infinity to negative 5/11ths. All right, last couple. Solve these, and then we're going to do set notation. So for this one, I get the x by itself, so I'm going to times by negative 3 times negative 3. When I multiply it by a negative, my sign has to switch. So x is less than, we'll cancel that out. So 10/3. Yeah, positive. So x is less than, skip that over. X is less than 10/3. So set notation would say x is real numbers, but x is less than 10/3. All right, 21. 5x and 8x. Let's go ahead and subtract 8x from both sides. And we end up with 5 minus 8x would be a negative 3x is greater than 27. Divide by negative 3. My sign flips, so x is less than negative 9. So my set notation is going to be x is real numbers, and erase this so I have some space for that. And x is less than negative 9. Okay, couple more. X divided by 4, so instead I'm going to times 4 times 4. X is greater than 5. So my set notation is x is all real numbers, but x has to be greater than 5. All right, over here, I'm going to distribute this one out to be 3x minus 21. So notice I have two 3x's. If I subtract 3x from both sides, those cancel, those cancel. So I'm basically left with -7 is greater than or equal to -21, which is true. So that means my set notation is x is my variable, x is all real numbers. Doesn't matter what I put in there, um, it'll work. All right, next one, 2x and 7x. Let's go ahead and subtract 7x from both sides. So I have 5x, -5x is less than -36. Divided both sides by -5. Then I have x, which my sign is greater than 36 over 5. That'd be positive because those are both negative. So then my set notation, x is real numbers, but x um, has to be greater than 36 over 5. Last one. 5 minus x, 9 plus x. Let's go ahead and plus x to both sides and minus 9 from both sides. So this one cancels and this one cancels. So I have -4 is less than 2x. So x is greater than -2. So my set notation would be x is all real numbers, but x is greater than -2. All right, and that is it for this one. Thanks for joining us. We'll see you next time.